Welcome to PEDIA's Cybersecurity series. In today's episode, we'll explore Arbitrary Code Execution, a critical security vulnerability that can have devastating effects on systems and data. We'll define the concept, examine real-world scenarios, and discuss lessons learned and preventive measures to keep your systems secure. Arbitrary Code Execution refers to a security vulnerability that allows an attacker to execute any code of their choosing on a target system or application. This can happen due to flaws in software, such as buffer overflows or improper input validation. Once an attacker gains this ability, they can manipulate systems in various harmful ways, from installing malware to stealing sensitive data. Let's consider a popular web application that allows users to upload files, like images or documents. The application fails to validate the types of files being uploaded properly. An attacker uploads a malicious script disguised as an image file. Because the application does not check the file's content, it accepts the upload without any issues. When the server processes the request to view the file, it inadvertently executes the embedded malicious code. This gives the attacker control over the server, enabling them to access sensitive information or deploy further attacks. This scenario illustrates the importance of input validation, highlighting that proper checks must be in place to ensure that only legitimate files are accepted. Developers should implement strict file type validation and adopt secure coding practices to prevent such vulnerabilities. Conducting regular security audits can help identify and mitigate risks effectively. Next, imagine a financial desktop application that processes transactions. The software has a known flaw that allows for buffer overflow attacks. An attacker crafts a specially formatted input that exceeds the buffer limit, allowing them to inject and execute arbitrary code within the application. As a result, the application crashes, and the attacker gains access to the system's memory, where they can extract sensitive user data, including financial information. Buffer overflows can lead to severe breaches if not properly managed, making it crucial to understand how data is handled in memory for application security. Developers should use secure coding techniques, such as bounds checking and memory management best practices, to mitigate buffer overflow vulnerabilities. Regularly patching software is essential to address known issues. Now let's look at a mobile banking application that allows users to make transfers and check balances. This app has a vulnerability in its API that allows for arbitrary code execution. An attacker uses a proxy tool to intercept API requests and inject malicious commands. By exploiting this vulnerability, they gain unauthorized access to user accounts. The attacker can manipulate account balances and even transfer funds to their own accounts without the victim's knowledge. Mobile applications are not immune to arbitrary code execution vulnerabilities, particularly through insecure APIs. To safeguard against these threats, developers should secure APIs by implementing authentication, input validation, and encryption. Regular security testing, including penetration testing, can help identify weaknesses. In conclusion, arbitrary code execution is a significant threat that can compromise systems and data integrity. Through our real-world scenarios, we've seen how vulnerabilities can arise in web applications, desktop software, and mobile apps. To protect against these threats, it's vital to implement strong input validation, secure coding practices, and regular software updates. By staying vigilant and proactive, organizations can safeguard their systems from potential attacks. Explore DG Info's innovative solutions in cybersecurity and join us in enhancing your data protection efforts. Together, we can secure our digital landscapes.